Leetcode on Christmas Day. That day being today. In terms of my solutions to this problem, I submit. I wanna copy that one and put that here. Also take out the glove 80. And doing it. Give me 1 second though. Gotta set up camera. Okay, well, this kind of works, right? So you can kind of see both my face and the keyboard. You see more of my body than my keyboard, so whatever. You can still kind of see that I'm typing. Does the job. Okay. So yesterday I tried this longest common subsequence problem again, and I do understand it better. This max basically gives us the choice of taking previous or taking one previous from a substring, either in text 1 or text 2. I know I've explained that pretty vaguely, so hope that's alright. However, in a few minutes, I gotta quickly do something. I'll be back. Okay, I'm back. Alright. Now, I wanted to watch the video solution.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve longest common subsequence, a dynamic programming problem. And this is pretty much one of the most popular dynamic programming problems. So we are given two strings text1 and text2, and we just want to return the length of the longest common subsequence between these two strings. And you might remember from my last video where we learned basically what a subsequence is. It's basically you take a string, right, like this string A, B, C, D, E, and you just, you choose a few characters from it while you maintain the order. So one subsequence from this string could be A, B, right? You take the first two characters from it. You can take any characters. You can choose to remove any characters. You can do whatever you want. And so we're looking for the longest common subsequence. So a subsequence that is in both of the strings. So in this example, we have two strings, right? A, B, C, D, E, and A, C, E. So what is the longest common subsequence between these? Well, when you take a look at the first string, you see that, hey, they both have an A, right? They both have an A in the first spot. So that's good. So now let's look at the second character, B and C. Well, this has a B, but the second string does not have a B. But the second string does have a C, and we also have a C over here. But the second string does not have a D, right? So we can't include the D from the first string. But then we see the last character is an E, the last character in the other string is also an E. So we get the longest common subsequence to just be the original second string, right? Ace. Because ace can be found in the first string. All we have to do is remove a couple characters, right? Remove the B and remove the D. Then we get look at the first string, you see that, hey, they both have an A, right? They both have.
Open. Big menu. So skilled. Cat.
They both have an A in the first spot, so that's good. So now let's look at the second character, B and C. Well, this has a B, but the second string does not have a B. But the second string does have a C, and we also have a C over here. But the second string does not have a D, right? So we can't include the D from the first string. But then we see the last character is an E, the last character in the other string is also an E. So we get the longest common subsequence to just be the original second string, right? Ace. Because ace can be found in the first string. All we have to do is remove a couple characters, right? Remove the B and remove the D. Then we get a subsequence that matches the second string. So the length of the longest common subsequence is 3. So how can we solve this problem? Well, as I mentioned, dynamic programming is the most efficient way to solve this problem. But before we even get into the dynamic programming solution, which is going to be a 2-dimensional dynamic programming solution, before we get into that, let's just notice one thing. So let's say these are our two strings, right? String 1 and string 2. Does it at least make sense to you that, okay, like we would want to start, let's say at the beginning of both strings, right? Like we're looking for the longest common subsequence. It might just be that both of the strings are actually equal, right? That could be a possible way. So let's look at the first character in each string. And in this case, they match each other, right? They're the same character. So does it at least make sense to you that if both of the characters match each other, right, the first characters, that the longest common subsequence, then we can break it into a sub-problem, right? Now, the new problem we're looking at is finding the longest common subsequence between the remainder of both strings, right? Plus 1, because we see that the first two characters are equal, right? That's where our 1 comes from, right? Because we know that the longest common subsequence is at least going to be 1 because we found a matching pair of characters, right? And then we have a sub-problem, right? And you might know that that's what dynamic programming is all about, finding the sub-problem. Now, what if this character was a B, right? And this is an A, so clearly they're not the same character. What would we do then? Well, we can't do what we just did. We can't add 1 and then find the longest common subsequence between the remainder of the two strings. We can't do that But we can break it into a different subproblem. We can say, well, it's possible that the longest common subsequence could be between these two strings, right? Or it could be between this string and this string. So this is just a little bit of an explanation before I show you the actual dynamic programming solution, right? Basically, what we found out is that based on comparing the first two characters, whether they're equal or not equal, we can break up the problem into subproblems and then solve those subproblems. So take a look what I just did. I took the two input strings, right? String 1 and string 2, and I wrote them in a different way, right? I said that this is a two-dimensional dynamic programming problem, and you might know that a grid, a 2D grid like this, is commonly used to solve these types of dynamic programming problems. So notice that for each character in both strings, there's a square.
Hello, Mr. B. Welcome.
Right? A position, a cell that we can put a value in. We're going to put a value in each of these cells. And so let's just start at the beginning like we did, right? So let's start at the first characters, right? What we're trying to do is for these strings, find the longest common subsequence between the entire strings, right? So what we're going to do is put that value right here. That's what's going to be the entire longest common subsequence. So we want to compute the value that goes here, but what you're going to find is to do that, we need to solve some subproblems and then, you know, continue to do that and then work our way back up to this position. So what do we notice? Let's look at these two characters, right? They're equal, A and A, right? So, okay, so now we want to find the value that goes here. How can we find that value? Well, like I mentioned, right, now we're trying to solve a subproblem. We want to find the longest common subsequence between these two substrings, right? We don't have to check these A's anymore because we know they match each other. So now I want to find this new subproblem, right? And so basically what I'm saying is I'm going to go here. I want to solve the subproblem that goes here. So now we're here, right? We're comparing this B with this that goes here. Basically what I'm other. So now I want to find this. Check these A's anymore because we know they match each other. So now I want to find this new subproblem, right? And so basically what I'm saying is I'm going to go here. I want to solve the subproblem that goes here. So now we're here, right? We're comparing this B with this C. We see that they're not equal this time, right? That means we're not going to be going diagonally. We're not going to look at this subproblem. We're going to look at a different subproblem. Since these characters do not equal each other, we have to check two different subproblems. It means that the longest common subsequence between these two substrings is going to be found in either of these two positions, right? So let's look at this position first. What this position tells us, we're trying to find the longest common subsequence between this string and this string, right? So basically we're not looking at this C anymore, right? And this position tells us that we're looking at the longest common subsequence between this string and this string. So basically when we remove this B, right? And just by looking at it, right, you can tell that this is going to, these two strings are going to lead to a longest common subsequence of 1. Just by looking at it, right, because you can see that this has one character, it's an E, it only matches this E, so that's going to be a 1. But when you look at this string and this string, right, corresponding to this position, we see that this has a CE, this has a CE, so this is going to end up being a 2. But let me actually solve the rest of it a little bit. So mainly looking at these two strings, right, in this position, we see that the C's match each other, right? So since, remember, when the characters match each other, the first characters of both strings match each other, that's when we go diagonally. And the reason we go diagonally is because then we know we can look at the remainder of both of the strings, right? We know that this C matches this C, so we want to look diagonally. We want to look at these two substrings. So what's the longest common substring between these two? Okay, so what are we going to do? Let's compare the first character, right? So D and E. So these characters are not equal. So remember what we do when the first characters are not equal. Then we can't go diagonally. So what do we decide to do? We go to the right and we go down and we take whatever the max of these two is and then put it in this value. That's what we're gonna do. So first, let's check this right position. So what does this right position even mean? It means we're taking this substring and finding the longest common subsequence with this substring, but this is an empty string. So what's gonna be in this cell? Remember, this is actually out of bounds anyway, right? So what default value are we gonna give ourselves if we go out of bounds to the right? Clearly, the longest common subsequence between a string and an empty string like this is going to be 0, right? So really, what we're going to initialize is we're going to say every value in this column is going to be 0. Similarly, this is an empty substring. If we were trying to find the LCS, the longest common subsequence between this and an empty substring, we would also get 0. So what we're going to do is put a 0 in these positions, right? That's just how we're going to initialize our 2D matrix when we start the problem. Okay, so remember what we were doing. We were at this position, we were going right and we were going down trying to find the maximum value. Well, clearly to the right we get a 0, so that's not the max. So let's go down. Okay, now we're down. So what are we doing? We're finding the LCS between this substring and this substring. Well, they're the exact same, right? E matches E. Okay, great. And remember, when characters match each other, that's when we look diagonally, right? So we came down here and now we're looking diagonally. Clearly, we get a 0 here, right? So 0 plus 1. The reason we're doing a plus 1 here is because we found matching characters. When characters match, we add 1 because clearly the LCS between these is going to at least be 1, right? At least one of these characters matches. So now I'm basically going to go here and then take us back along the path that we came from and then show you what the solution is. So we had a 1 here, right? And so from this position, we went down. So since we were going down, that means that this character and this character did not match each other. So what we're going to do is just take the 1 and put it up here, right? So there's going to be a 1 here because the LCS between these two is 1. But now we're going to go back over here diagonally, right? Diagonally means that this character matched this character, right? So we're going to take the value that we got up here, put it over here, and add 1 because remember, these match each other. So we're adding 1. That means we're going to end up putting a 2 in this position. And now we're going up, right? We're going up because that's where we came from. And remember, when you go up, that means the characters did not match each other. The C and the B don't match each other. So we're going to put a 2 here, right? We're just taking this 2 and...
Okay, give me a sec. I want to finish nails and then I'll be back. Okay, no need.
putting it over here. And lastly, we're going back here. That's where we came from, right? Diagonally. That means the characters were matching each other, so we can add at least 1 character. So 2
The biggest problem
1,
is identifying subproblems.
This is how we got the result, right? So we got a 3, meaning that the LCS between these 2 strings is 3, right? And that's what we learned from the problem explanation. So, right, what we're going to do is return 3. That's our result. But you can see that the way I did it was basically intuitive, right? I used this picture and basically solved this problem by hand using a little intuition and stuff, right? But the way we're going to have to solve this with code is going to be brute force-ish, right? So it's dynamic programming, but what we're going to have to do is for every value in this cell, right? So we are going to initialize these zeros, right? But with this matrix, right, this 2D matrix, we want the value that goes up here, right? And to do that, we have to compute the value that goes here, that goes here, that goes here, and basically for all these, and then finally we'll be able to have the value that goes here, which is the result that we're going to return. And so basically what I'm saying is this is going to be a bottom-up dynamic programming solution, right? Bottom up. Basically do that, we have to compute the value that goes here, that goes here, that goes here, and basically for all these, and then finally we'll be able to have the value that goes here, which is the result that we're going to return. And so basically what I'm saying is this is going to be a bottom-up dynamic programming solution, right? Bottom up, meaning we're going to solve it in reverse order. We're going to first get every value, we're going to get the value that goes here, and then work our way up until we get to the result. And you might have noticed, see, I have an I that tells us the column, I have a J that tells us, actually the column, and the I tells us what the row is. And so when we're working our way, starting at the bottom and then working our way up, how are we going to determine what value goes in each cell? Basically what I went over earlier, right? So we're going to look at the characters.
So disregard the green while he goes this green, right? Let's just say that, you know, we're talking about subproblems. Our two strings are A, B, C, D, E, and ACE. As you build a subproblem, as you look at the subproblems, each subproblem is a cell, right? So once you build the, say the subproblem of E and E, right? This is the very, very almost base case subproblem. That should equal to 1. Because you notice E and E are equal. So then this, the longest common subsequence for E and E is 1. And how do you get 1? Well, in the algorithm that is expressing, it's going to be 0. Sorry, it's going to be 0, this 0, plus 1, which is going to equal to 1 here. And then you look up at, or you look at the subproblem, because we're doing this in a bottom-up approach now, is what he was expressing just a minute ago, that you will have to now look at the subproblem of E and CE, right? CE together. And then you notice that is also 1, right? You just from intuition, you'd notice that it's just 1 because, well, there is only the longest common subsequence being E. So the length would be 1 here. Then he would say, okay, since C and E aren't the same, right, we have to look at the bottom here and the one across from us. And then looking at these two, because this is already just found from before, we can use this value. So this was 1 and this was 0. Take the max of the two and you return that here. So this 1 gets just put right here into the CE and E subproblem. Right, and that's true because look, that the one that goes there, the one that goes on, you know, this specific column, sorry, this specific cell is correct because it's CE and E. Right, CE string and E string. The longest common subsequence of that is 1. And then you keep on doing this, and that's how you get the final answer. So you would continue doing all these subproblems, right, all the way bottom up until you reach A and A. And once you reach A and A, that becomes the problem. It becomes the problem, right? It becomes the problem that we're trying to solve. And still a subproblem, you can think of it, but it's also the problem. So, you know, once we reach here, it becomes A, B, C, D, E, as string 1 and ACE as string 2, right? That is our problem that we're trying to find the longest common subsequence of. And then we'd expect that value specifically to be equal to 3 because, you know, the longest common subsequence here between A, C, and E and A, B, C, D, E is 3. So hopefully that I did maybe yap a little.
And if they match each other, what we're going to do is say 1 plus the value that's diagonal, right? And we know when we go out of bounds, there's a 0, right?
Now
there's
we can continue to finish working
0
this.
when we go out of bounds. And we're going to do that with every single cell, right? So when you look at these two, we get an E and a C, right? And when characters don't match each other, right, that's important. What we're going to do is we're going to look down, right? We see a 0 down here, and we're going to go right to the right side, and we see a 1 here on the right side.
So this is exactly the explanation I was about to say.
Max of those two values, and we see that the max is, of course, 1, right? 1 is bigger than 0, and then we're going to put that max value in the cell. So that's really it. There are two choices, right? If the characters don't match each other, right, in this case, or if the characters do match each other in this case,
come
right?
on.
That's basically how we're going to solve this problem. It'll make a little more sense when I show you the code. So remember, we're going to have a 2D grid. So I'm going to call that DP for dynamic programming. It's going to be a 2D grid. And what I'm initially going to do is set it to all zeros, right? So, and I'm just going to do a little bit of Python stuff. So list comprehension in Python. So we're going to go through every single value in the length of text 2 plus 1, right? Plus 1 because we know that we need at least one more column to have all the zeros in it. And so remember, we're going to put a 0 for every value in that. So length plus 1. And we're going to have this row for every value in the length of string 1. So text 1 plus 1 as well, right? So we're basically, if you're not familiar with Python, this looks complicated, but basically we're getting a 2D grid of dimensions length 2 plus 1 times a length string 1 plus 1 and initializing it to all zeros. And then we're just going to have a nested loop. And what we're going to do is iterate through this 2D grid in reverse order. So in Python, you can do it like this, and basically what I'm doing is starting at the bottom right of the matrix and then working our way up. So this is how you do it in Python, -1, -1, and let's do the same thing for text 2. And so remember, so we're going through every cell in our 2D grid, and remember there were two conditions. One condition is if the characters in both strings match each other. So if text 1 of I matches text 2 at position J, if they match each other, we're going to do something, and if they don't match each other, we're going to do something
dynamic programming problems.
So remember, if they do match each other, then what we can say is at this position, dp of I, J, because remember, we're trying to fill in every single cell, what we can do is then just simply take 1 plus the diagonal. How do we find the diagonal? Well, we can say I plus 1 and J plus 1, right? That gives us the diagonal. And remember, we're adding 1 to it because these characters match. That means we add a 1. And if they don't match, that's the else case, right? So we're doing something different here. We're going to put a different value for dp of ij. And in this case, what we're doing is we're finding the maximum of two values. What are the two values? The value to the right of this position, so we can say dp of I, j plus 1. We can say that's the right value, and the value below the bottom value. That's probably my biggest issue is not understanding how to identify and j for that, right? So we're finding the maximum of these two. We're not adding 1. We're not adding 1 because the characters did not match each other. But basically, literally, these are the two cases. We're just filling in a different value depending on what the case is. And that's it. So literally with these two nested loops and with these two conditions, we're filling in the entire DP matrix And so once that matrix is filled in, we know that the result is going to be at the top left of that matrix. So the DP, the matrix at index 0, 0. That's going to have our result. So all we have to do now is
Arguably,
return the result. And
edge
clearly you can see
cases
that the
aren't my
time
biggest issue.
complexity of this is the length of the strings multiplied by each other. So if the length of string 1 was n and the length of string 2 was m, we just multiply them together. So this would be the time complexity. That's also the memory.
It's like you have to, when it comes to edge cases, like you have to think at a low level. And then when it comes to thinking about problems in DP, you have to think at a high level. So both combined is probably the challenge. And I'm convinced that you might be better at thinking about things at the high level. And I'm more inclined to think of things in the low level. Now, by low level, you know, I specifically mean like the variables, how they must, you know, be initialized to get what we want in the end. Something like that. Okay. Regardless,
complexity because we need extra memory for our 2D dynamic programming grid. Oops, I had just one little bug. I added one to the inside of that function, but I needed to add one here. But other than that, you can see that the code does work, and it is pretty efficient because the dynamic programming solution is the most efficient for this problem. So I hope that this was helpful.
Okay, oh wait, did I?
Basically when we remove this B, right?
Okay, the other aspect of this, what am I saying? The other aspect of my computer right now, this computer, is that it's super slow to load shit. I want to get a new laptop, man. So bad. Get a new laptop so bad. Okay. Okay. Okay, let me close this. All right. Thing is, right, that we could do a problem. Or we could try something new. All right. Now, if we do some more practice, and the fact that I'm pretty close, dang, to finishing blind 75, I need to take a look at some greedy maximum subarray. Maximum subarray. You got a refund from FAFSA. Picking up the new M4. Think about it. Think about it. Except what is FAFSA? Okay. A free application for federal student aid. Yeah. I am not in the US. Let me change this it's just the school loan. I get what you mean. Okay, yep, that works. Okay. So my thinking, right, for this problem is I'll try do a little bit. We're gonna say we're gonna cap it at. Ooh. I will have to cap this at 15 minutes because I gotta get ready for something else. Shit. I should cap it now. I'll read the problem and I'll call it a day. I gotta go to something tonight. But regardless, I think looking at that Leetcode problem before, that longest common subsequence problem, is a really good problem to understanding dynamic programming. And just like the other day, someone in chat said that if you can solve this longest common subsequence problem, you can solve about 10 other dynamic programming problems. So I probably believe that, and regardless, it's a win for me. With that said, let's have a read through this problem before we call it a day. And I know you can't really read the problem because the chat's kind of covering it. Okay. Given an array of integers, nums, find the subarray with the largest sum and return the sum. Subarray. A subarray is a contiguous non-empty sequence of elements within an array. Why does it feel like I've done this problem before? Again, there was something about subarrays as well that I've done. Let me just quickly check that. I should try and find it. Subarray. Oh, I should say bottom up dynamic programming. Okay, let me try and look now at subarray. Maximum subarray. Maximum product subarray. So is this not the same thing? Unless you just really want me to do it again. Maximum subarray. Subarray 4 has the largest sum of 8 because if you go 4 minus 2 plus 2, 1 plus 1 is plus 4 is equal to 8. I believe that. I believe that. And then this is meant to be a dynamic programming problem. Right. Right. Okay, so it's meant to be like a dynamic programming problem. What is this? Bit manipulation? No, is it? Let me check this. Let me check this. Practice. Line 75. Greedy. Maximum subarray. The greedy. Before you go, I'm interested to see how graph looks on Obsidian. Alright. I will show you in just a moment. So this problem is very interesting to me. Maximum subarray. It has to be the same. It has to be the same. Adani's algorithm. Okay, so Adani's algorithm. All right. Regardless, if it comes up twice, it means you have to do it. So I believe maximum subarray should be here again. Okay. Or not. Did I just not write it? Wait, let me... Did I just do the problem and not... mark it? Leetcode 150? Perhaps. But I've done it here. And when was this? I wonder if it was a problem that was recommended to me by someone. And then I just did it anyway. Okay, regardless, that's fine. We'll do this problem next time. I mean, basically it's just this, whatever I have here. But it's good to revisit this. We will revisit it, possibly after. Let me show you my graph. Oh, it's gonna take some time. Gonna take some time. Yep. It's loading very slowly. Okay. Okay. Zoom out even further. Slowly, okay. That's it. It's a humble graph. It's a humble graph here. Given how many years I've technically had this already. It almost blew up your Mac, exactly. 100%. It almost did. So unfortunate. I wonder, like, this is a subject, right? No, it's Excalibur. Excalibur alone is this many. Cryptography. Alright, yeah, I can get how that can be like that. Where are all my Leetcode? Alright, doesn't matter. I won't expose myself too much here, but yeah, alright. That's it. Alright, tomorrow we'll come back and do maximum subarray. Most likely. Alright. Yeah, you too, Nahi. Thanks for joining in. Catches. Peace.